I'm really excited to be here at DefCamp. I think that getting together like this is really important to be a community, and we should meet as often as possible. So it's really great. This is how we learn. This is how we grow. Orange is the new purple. I'm April Wright. I am a security generalist. My knowledge is a mile wide and an inch deep. I do pretty much everything. I've done blue team, orange team, red team, and I focus on the security of everything, basically. I'm a former developer. I did write really bad, insecure code. I'll admit that. But I'm a hacker. I have several. A security-focused degree and several certifications. I travel around the world speaking about infosec and process, which I know is not quite as sexy as the latest vulnerability or something like that. By the way, you're a very lucky group today. I did this talk at Black Hat USA this past summer, and this presentation has significantly more cats in it. Right now I work on SDLC programs, so software development life cycles, trying to build more secure software. I analyze and build overlay programs to software that is often already being built and has no security built in. So I use a lot of soft and diplomatic skills to have influence and get things done that are sometimes seemingly impossible. I have a lot of insight into this from all sides, as I said, and from my experience, it is the best way to secure an infrastructure and an environment is to start with secure software. So I work for Verizon, but I am not going to try to sell you anything today. So let's talk about software. Essentially, the only group who cares about security are the people who understand how important it is. So it's our responsibility to convince everyone else to care. We are the ones who must drive security into the organization's culture, which impacts all of our software. So buy-in from top management can really make or break a new project, an effort, or an initiative. If the executives don't care, then you can bet that the engineers aren't going to either. You've probably noticed that security and the builders of software do not see eye to eye. By builders, I mean programmers, architects, engineers, etc. And it's true, we don't see eye to eye. We have very different goals. We want to start with something secure. We want to make it secure, keep it secure, prove it secure through compliance, and then hopefully shut it down when it can't be secured anymore. But the application builders, they have tight deadlines. They're just trying to make code that does what it's supposed to do, which if you've ever written code is by far the hardest part. There's no room for security in the current model, and so security ends up being an afterthought in a lot of cases. As security, we also have a really valid image problem. So once a year or once a quarter, if we're lucky, security will come in and will audit an environment. We'll do a pen test or some consulting. We'll tear apart their work, we'll criticize their art, and code is art, I believe that. We destroy their creations, and we give them a lot of unscheduled work to do. They don't like us, and we're really at war with the developers and the creators of the software. So there's no teamwork, it's a battle, and it's easy to see why we would be perceived as negative or annoying to non-security people. So instead of giving praise, we're giving them a spreadsheet. We're giving them more work, and the status quo is not helping us build more secure software. So why do we have these different goals? Why doesn't development care about security, and can we actually productively work together? I think we can. But we need to start in a new place. If security audits once a year, then who's in charge for the other 11 months? It's the builders. So it's extremely critical that we fix this problem with us not communicating. We really need to be on the same team. So besides different goals, we also have different challenges. For instance, we can't secure what we don't know about. We don't know all of the libraries that are being used in every piece of software, but the developers do. We tend to be shocked when things aren't done securely. It seems like really simple to us. Why did they do that? They should know better. Why did they write their own cryptography? We just don't understand some of the things that builders do. We also cannot keep up with Agile. Agile is very fast, and a 2 or 4 week code turnaround, we just can't do a pen test on that. It's not possible. It's also strikingly apparent that we have silos of knowledge with security. You have a security degree, you have security, you do security all the time, but developers and other people do not do that. They are not exposed to security. And that really starts in education, but I'm not really going to get into that. So because of the separation of security and developers from the beginning, they just haven't been exposed. And there is this problem, you've probably seen this before, you can have 2 but not all 3, and this is definitely true when it comes to software. The corporate status quo is famously quoted by the founder of LinkedIn as saying that if you're not at least a little bit embarrassed by your first release, you've released too late. But that's a terrible status quo when it comes to security. Because if you've released too late and you're embarrassed by your software when it comes to security, it means that you've been breached, it means that your data is compromised, your brand is damaged. And by expecting software to be created in a cheap and fast manner, an organization is totally ignoring the long-term goals, and it really translates into more expensive later. Why is that? Well, after software is created, the software builders are supposed to be working on things that drive revenue. So that's improving features, adding stability. Those are the things that make money. Security doesn't make money. We're a cost center, and it's a bit like insurance against having to pay a lot more later. But we can improve software by partnering with the builders, not policing them. We have a secret shared goal that I haven't mentioned, which is that we want the organization to be successful. We all want that, every team. Developers, the builders, they do not have the resources to build securely, whether it's time, whether it's knowledge, whether it's permission to do so from above. We like to share our knowledge. I will talk to any Uber driver ever about how to protect themselves from ransomware. We just do this, we talk to people. But we need to create more opportunities for the builders to listen to what we have to say. So as like all things security, we can solve this with a triangle. We love our triangles in infosec. We need to consider builders as part of the same team. So when I talk about red, I'm talking about anything that has to do with finding vulnerabilities, testing for vulnerabilities, offensive testing, penetration testing, vulnerability scanning, code reviews, those sorts of things. Blue, as you probably know, is detection, forensics, incident response. And yellow is the new concept that I'd like to talk to you about. These are the app developers, the software engineers, the designers, the architects. We've given them a color, let's bring them into our world. Let's be on the same team. And the important thing here to remember is 2 primary colors, we've got secondary colors, and I've got hex codes here for people who are colorblind like myself. The purple team is not a new concept. This is a really great example of security teams joining forces and creating a same team mindset. There are limitations though, which is that it doesn't address the upstream source of vulnerabilities. Where are the bugs coming from? Why are there so many? There's also an inherent delay between when a bug is created by a builder and found by a testing team, like a red team. And the red team is also basically looking for known vulnerabilities. So a program that relies purely on offensive testing to secure its software is always going to be problematic in trying to catch up. It's like trying to remove the needles from a haystack. So most of us understand red, blue, and purple, so let's talk about the orange and green teams. Software defenders and software builders should be meeting much more often. We should be best friends. We can do great things together if we work as one team. And an example of that is the orange team, which is red and yellow working together. Red is showing yellow what dangers are possible. Through this combination, yellow is continuously exposed to real-world threats, not just as a bug, but as teaching the nature of the vulnerabilities they're finding, and then yellow can incorporate this knowledge into what they do. So yellow has to be able to think like an attacker in order to build defenses against those attacks. An open door policy between the teams allows for collaboration on a constant level, and they can work through any questions or possible threats that are found. And through this model, Red should ideally never find the same vulnerability twice. When Yellow team learns about a security issue from Red, they may realize that that same bug or a very similar bug is found elsewhere. It may be outside of the scope of the Red test that's going on, and Yellow may realize that there are other bugs like this and they should change them as well. If Yellow considered security mandatory, and Yellow's aware of and educated about attack methods, then their idea of correct code will become synonymous with secure code. It's always better to prevent a bug than to find it later and fix it. Every experience with Red and Yellow should be a learning experience. It should be very positive. We should never have negative experience between security and developers. It doesn't make us look good. It doesn't help build the relationship. So by developing the threat-based mindset, we can prevent many vulnerabilities. As we discussed, the priorities of the builders are on time, working, and correct. So not only can security be a cost center, but lack of security can be a huge burden on the organization in terms of money and time. Some significant flaws will be unfixable. Some of them won't be easily fixable. And this is why identifying flaws before they go into production is so important. And let's, just so we're on the same page, a bug is very easy to fix. It's a code problem. And a flaw is something that comes about in design and architecture. Flaws are significantly more difficult to fix because of that, because they are design and architecture related and not just something that can be quickly fixed in code. So the green team is blue and yellow working together, making improvements to all of the blue functions. And what does blue want? They want to know how, who, when, and where. So this capability can be improved based on either blue findings or purple findings or known limitations that yellow is aware of. And if detection is not as good as it needs to be, or if you need heightened introspection in a certain high impact area, you can add it via the developers. Logs can come out standardized so that they're easily plug and playable into SIEM. And they can have all of the important information that Blue would need to do an investigation or to do forensics. So through this, Blue also gains a better understanding of the actual software that they are trying to defend. Enhanced logging can be implemented. You can set up traps so that when an attacker and an attack scenario or an indicator of compromise is found, then you can actually quarantine what's happening, increase the logging temporarily for that session, and other things like that. You can also make software easier to patch. So if you can create redundancies within the software, then the operational security that has to occur after production can be a lot easier if the developers have thought about that being a necessity when they're building software. So yellow, orange, and green, it's all just a theory for improving software before it ever becomes a red team bug or a blue team incident. We don't want security to be tacked on later, we know this. So being a team, as I refer to it, does not have to be overly formal. In fact, it's probably better if it's not. We just need to work alongside each other. Some ideas for this that I have are temporary job swaps or shadowing, duty rotations where a yellow team member will sit with red while they're penetration testing and see what they do and see how they think, or sitting in with a blue team analyst as they do their job and looking, seeing what they see, seeing what they don't see, and that communication can be really powerful. So when you're trying to build more secure software, the very first hurdle that you're going to have to jump through is setting expectations. So what do I mean by that? When I talk to project managers and project and product managers, one of the things that they always ask for is detailed documentation about what needs to be done. This helps them. and they can work with that type of information. They understand it. We know that the secure end state, we know what that should look like. So the project managers can help us get there, but we have to tell them how. So checklists help everyone know what to expect. And I know the checklists are totally boring, but if we use them, then everyone besides us knows what needs to be done, and then security gets built in. Also, having management on board for all of this is very important because they will back you when you present new requirements to the project management organization and you say these are our expectations and these are the new requirements, and they'll say no, 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 we don't want to do that because it's too much work, and management will say yes, you have to do that. So that is very important. I'd like to present some practical SDLC security tips. Maybe you already have security in your SDLC, maybe you don't. A lot of existing software has been written before security was hired even or involved. I spent the last several years analyzing really broken security programs and injecting security along the way at various stages. So testing with red teams and detection by blue teams, they're both finding problems after the implementation, and it may already be too late at that point. So we start with a checklist, we think about what needs to be done, we think backwards from the goal. We as security need to feel happy before we approve something to move into the next stage. And we need to think about what those things are that will make us happy. Project managers really want to help us achieve our goals, but they have to know what those goals are. So I get asked all the time, what are the next steps? What needs to be ready? What should we plan for? And if you can't provide that information, it's not going to get done. They need to understand step by step, everything, timelines. They will start gathering requirements and coming up with timelines very early in the project, as well as costs. So if the timeline slips, then security is going to be one of the first things to get pushed to the side. You may not know exactly how long a task is going to take at first, but as the process matures, it will start to be solidified. So your best guess, at least initially, is good enough for a PM. With PMs, the management, the builders, security, we don't want them to feel like there's any scope creep. So we don't want to impose new requirements all the time on them, which is a big reason that the checklists are so popular, because then they say, okay, these are the things that need to be done, and there aren't a whole bunch of, okay, well now you need to do this, and now you need to do this, and go, no, we didn't expect that, we can't do it, and we don't have time. That doesn't happen. So after a while, many of the tasks that we set up with the PM will become fairly hands-off, because the PM can manage all of those tasks on their own. And if you are like me and you have no idea how to use Microsoft Project, you can just start with a bullet list, you can start with a spreadsheet, and eventually you can have it turned into a project plan that they can literally just import and for any project that they're working on. So I'm not going to go too much into the checklist. I know we're short on time, but I do have a real world story about why these are so important. So there was a project that I was working on, and they had purchased a networking switch during what was supposed to be a planning stage. So after they left the planning stage and got into design and architecture, they started working with security. And they realized that we needed ports for spans for network IDS. They did not have enough ports. They should have bought a bigger switch. So that was a very expensive mistake to make. They were able to work around it, but that could have been prevented by us being involved very early on, from the beginning of the project. So when we find out what data exists, where it lives, and why we have it, that's an essential part of GDPR, and we need to also know how long that data is going to be kept. So being transparent about that helps build stronger relationships with consumers, but it also helps us determine privacy requirements and where we really want to spend our money to protect the data. So privacy questionnaire is a great way to talk about how we want to protect the data and what is really there to be secured. So this is a living document. We want to keep this updated throughout the SDLC. A use case, as you probably know, is a formal requirement specified as if, as a so-and-so, I want to be able to do something. So ideally, you want to create a set of these that are generic enough that they can be reused again and again in any project without a lot of customization. And a misuse case is something you may or may not have heard of. It's a formal specification of really thinking like an attacker. So as an attacker, I want to be able to do this. So the acceptance criteria, which is always testable, needs to be the opposite of the misuse case. So we don't want them to be able to do what they want to do. You will almost definitely have to explain these to PMs and developers because nobody else knows what these are. They don't teach this to them. Design and architecture checklists. We can tweak these. Not everything's going to apply to every environment, but a prototype should always incorporate design and architecture security requirements. So we have to approve any software before it moves to the next stage. And there has to be a policy in place that says that we will not allow software to move on unless security is okay. So who are the vendors and what is their security like? I absolutely love this story. This is Bossy, and he works at a company here in Bucharest. I cannot emphasize enough the importance of vendor selection and supply chain management for SDLC security. Third parties and third-party software continue to be a primary vector of attack today. So why is this so critical? Well, if your most secure software is out there and you have it, it's the best thing that's ever been built, that can totally be compromised and undermined and sabotaged by your third-party vendors. This happened to Target, although I don't know that I'd say that they were the most secure place out there, but this is a common way that people get into companies is they will compromise the third party and use it as a vector. So we need to make sure that they follow at least the same level of security to create their products as we do to create ours. We rely on people like Bossy. And so we want to know what their security is and what their posture is so that we can understand the risks that we're getting into. So to determine the third-party security, we want to have working sessions with the vendors. Telepresence is not adequate for this. We want to do this in person. Being able to use a whiteboard and have somebody diagram out what their product is doing is so important. An example, I once had a vendor come in and through extensive whiteboarding sessions, we found out that they were using passwordless SSH as root to do automation within the platform. It's a storage platform. They also wrote their own web server. So that was fun. I'm sure it did what it was supposed to be doing really well, but the security was just not there. So if we had implemented that, that would have had a major risk that we would have added to our environment. Several major risks, actually. So you want to have a development and implementation checklist that talks about all of the requirements coming together when things are actually being built. Critical things like monitoring and patching, those should be in place before it goes into production, not after. We shouldn't be lazy and say, okay, we have this date for go live, we need to get this out there, and then we'll add all this stuff later because it won't and it may not work. Let's say that all encryption, let's say that you're encrypting all of your storage traffic. You may realize after production that this is really too costly in terms of performance. So understanding that limitation before going into production is really important. And so that's why everything needs to be reviewed after design stage. You need to have a prototype. You need to be working through this with security and trying to agree on really what should be out there before it goes out. So the really important thing here is that we want to be able to provide all of these checklists up front to the PMs, up front to the development teams, so that they understand what needs to be done from the beginning. If we don't do that, then we're hurting ourselves. We need to add buffer time into all of the estimates as well. But sometimes PMs will do this, so you need to understand if they're going to add buffer time or if you need to add buffer time. But things always take longer than they're supposed to, as we know. So let's say that you want to add a server or a bunch of servers into monitoring for vulnerabilities. That may take a couple of days, so you just say 3 days. And then you have to have some sort of link or a description of the process for them that they need to follow to request those servers being added to vulnerability monitoring. They have to understand what needs to be done, how long it will take, and then they can do it. If they don't understand that, they're not going to do it. So one of the most frequent questions that I'm asked is, how do we use compliance to get more secure software? And I came up with kind of a creative solution, and that's that because most compliances do not require SDLC security, they don't require that red and blue teams work together or red and yellow teams work together. They don't require security mindedness or training. The advice I usually give them is to stack security requirements. So when you add something to your policy, compliance will come in and review your policies and say, give me examples that you are doing everything that you say in your policy. They'll want evidence and artifacts saying that something, let's say that you say, our red and yellow team works together at least quarterly to review changes to the software. They will check to make sure that that's been done, which is a real driver for getting that change made within the business. So using policies is so powerful. Policies can get anything you want done. So if you can get something into a policy and approve, then it will happen. If you want to start improving software security, collecting metrics now is really important because of trending and things like that. If you don't already have them, you want to be able to explain how things are improving and the ROI and all that fun stuff. Besides trending, you want to keep track of who created the highest number of vulnerabilities. If somebody continues to create insecure code, they should be trained again. They should have working sessions, and eventually your policy should say that maybe they'll be terminated. I mean, creating insecure code is really dangerous for the company, and if it keeps happening and they're doing things like OWASP top 10 mistakes, that's just bad code. That's not a problem with anything else. It's a problem with what they're doing. So one motivational approach I have for this is to track who finds the most vulnerabilities and who has the biggest decrease in vulnerabilities after a training. And you can reward them. You can give them prizes or recognition or something like that, because positive reinforcement is always better than negative reinforcement. Metrics really do not answer the fundamental question of why we're getting vulnerabilities. So once you have the data, you want to present it up to management. The C-levels care about decreasing risk, and they want to know about regulatory compliance issues and legal risks. They want to know how to solve important problems. CXOs need to understand how the application security program has improved, what's being done to decrease risk, what the residual risks are to critical operations and key projects, and how those residual risks can translate into threats that are facing customers and the company. But collecting metrics is not the end. You have to use them. Don't keep them in a PDF or a spreadsheet. Make sure they get into meetings. Make sure they get to the people that need to use the program. And be sure it's in a format that they need. Get them out of tools and reports and get them into the developers' brains, really. So how do we gain management buy-in? This is a big question that I get asked a lot too. The metrics are a good way to talk to management. They like to know all about the numbers and the money. For example, the cost of bugs increasing significantly as they move through the SDLC is something they would like to know about. A working risk management program can definitely help. However basic or advanced, just identifying and scoring risks that management should understand and make choices about. We can ask them what problems they want to solve in the business and what are their security goals. They'll probably talk a lot about patching or IDS coverage, other operational issues, and these are always the most present and visible. So if their goals don't include software security, it's our job to tell them that they should. We should ask them why they don't include software security. They may not even understand how important it is to start with a secure baseline in order to have those operational tasks be easier. So people will push back on change. It's human nature. We don't like to change. So be ready to address any concerns that come up. Not everyone will want what you're trying to do. So it is ultimately in everyone's best interest, but it should be a need, not a want or a nice to have for the organization. And we can bring about positive change in a number of ways through really social engineering at work. We can start with empathy. If we listen to the developers, we can express that we understand their goals. We understand that they want things to be on time and they want to meet their deadlines. If we work within their framework of relevancy, and we're not just going to be a roadblock to them, then, or create more work for them, then they will appreciate that. Second, we can build rapport with them by letting them trust us. Will we fulfill our promises? Will we make them look good? Do we have reliability? Do we come through on our promises? The third thing is that we want to ensure people are working with us, not against us, and we want them to do it on their own free will, but they may not want to, so that policy does come into play here. So force and using your management is definitely key. Another driver of change is customer contracts. I don't know why companies don't want to be secure before the customer comes in and asks them how secure they are, but for some reason customer contracts are a good way for companies to change. They always want to beef up security to meet the requirements of the customer. So we want to change the organizational culture. That's what we're talking about here. We want production-ready software to be correct. And the entire company needs to understand this. And we need to have security as a core value. It's our job to sell that. It's nobody else's job, it's us. We want to sell it to our peers, to our management, to the board, to your director, to everyone, coworkers even. Anyone that can help make change happen. So I suggest you make a plan to shift the culture, to get buy-in, and to elicit change. Make a flow chart, make a mind map, a decision tree, whatever you like. Come up with any level of roadmap of where you want to be. You can think of the small steps that you can take to drive system security and make the company care more about it. Since we understand what secure software should look like, and like the process checklist, we can start with the goal and work backwards. Think of what kind of training can be offered to developers, to the stakeholders, to the builders, and make it available. You can have lunch and learn sessions. Find out what works for your team. It will not be the same for every organization. You can just ask them what they're interested in. Free pizza goes a long way getting people to come and listen to you. Make sure you plan time to work on these things, and that's why management buy-in is also important, because management will say that, yes, you have time to go to this and learn about security. So it is our responsibility to make sure that the organization wants security. We have to make people understand why it's important for them. This, again, is a social engineering tactic. Until we're all equal stakeholders, that us versus them mentality is going to perpetuate. When someone understands how important security is, how could they neglect that? How can they not make things more secure? We want to acknowledge the fact that change is going to take adjustment and explain how change will affect them positively. For developers, fixing things is just not fun. So tell them they'll have more time to work on things that they are excited about. They can learn new things instead of fixing bugs. Tell them that they'll get training. Tell them that security-minded developers make a lot more money, because that's true. We can also gamify security, like the perks and prizes for people at the end of the month. That will make them care, or if there's $100 on the line. So for executives, we want to talk about money, 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 money. They want success for the organization. They want less phone calls during their golf game. They want to understand the decreased costs and how their budget will be positively impacted. And we should also talk about intangible costs, like harm to the brand, that could be caused by a breach. Implementing security should be easy, it should be intuitive. We can have libraries that are customized to include security. We can disable insecure functions. We can have code reviews that include the yellow team and the red team working together, where the red designs the review, they create the review rules, and then they go over the findings with yellow. This shouldn't just be yellow running the defaults in a piece of software for code review. It should be a team effort. It should be the orange team working together. We should never be finding preventable issues like cross-site scripting or anything in that OWASP top 10. That's just bad coding. That's totally avoidable. So everything when you start is going to be incomplete, and it's okay. We have to start somewhere. Don't get discouraged. It will mature over time. It will get better and more comprehensive, and the timelines will get more solidified, and things will become leaner and faster, and through the metrics we'll be able to show that that's happening. So the point of those checklists is to set the expectation that security is going to be part of that SDLC, whether they want it or not. And going forward, it will set the entire team up for success. There will be less failures because security is not a hindrance to the process. And when the process succeeds, the business succeeds. And that is, like I said, everyone's goal. So extra time and effort are definitely requirements in this. So being on the same team starts with that leadership buy-in, and they have to allow resources. So I suggest you use the policy, break down the silos of knowledge, work towards goals together, open those lines of communication, be more positive when we interact with builders, tell them what they did right, not just what they did wrong. So if the red team runs up against something that stops them from a certain vector, tell them, say, you did this right, and do it again. That's awesome. We don't just want to give them the negative findings all the time. We want them to want to work with us. So if we sacrifice our time training others, then we're rewarded with decreased risk and an easier environment to keep secure. This isn't going to happen overnight or as quickly as you want it to. Small changes can be made today, tomorrow, which is good because today we have a gap. We have a divide within our organization that separates our developers and our defense teams, and it's detrimental to the security of our software. I always say that it's both our duty and our privilege to be able to share our knowledge. We have a lot of knowledge. We have a lot of good ideas. And when we elevate others through teaching, we elevate not only that person, but we elevate ourselves, we elevate the entire organization, and the many direct and indirect customers and the users of our software. So I challenge you to include both offensive testing and defensive building in your security strategy. It's not one or the other. Because offensive testing and incident response are not replacements for good code, strong architecture, and a threat-based design. So that's all I have. Thank you.